All right. Good evening, everybody. Hopefully you can hear me. I was the one holding up the meeting, so I was told let's get over here. If everybody will stand and we'll say the pledge. Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, liberty and justice for all. All right. Good evening. As always, I'd like to go around real quick and just introduce the board members because I know there are some new faces here tonight. So that way everybody knows who is who in the organization, at least the ones that are present and accounted for this evening. Myself, I'm John Knott. I am the president of Orlando Amateur Radio Club. I'm also the EC of Orange County Areas, and if I keep turning the hat around, it'll have a title on each one. Michael Cawley is over here running the audio visual tonight. He is the vice president of Orlando Amateur Radio Club, and he is the general chairman of Orlando Hamcation. Bob Nocero standing up over here on this side of the room. Bob is the secretary of Orlando Amateur Radio Club. Anna Groh is in the back of the room, standing up, waving her hand. She is the treasurer of Orlando Amateur Radio Club. Sitting next to her is Dean Groh, her husband, and one of our directors on the board of directors. James Dool is right there. James is also a director. Ed Thralls. Ed's over here. Frank Gerkes is not here this evening. Bob Cumming is right here up front. And Frank Tagalani in the back of the room. Also, these guys are all part of the board of directors as a director on the board. So please, anybody ever has any comments, questions, concerns, ideas, suggestions, you want to beat somebody up, throw some punches, these are the individuals, we are the individuals you want to do that to. Any one of us, if you have comments or questions or suggestions or anything, please feel free at any time to email one of us or talk to us on the side, whatever the case might be. We are here to represent you as a member of this organization. So if we don't hear from you, we can only assume everything's hunky-dory, all right? Even though you might be upset about something, unless you tell us, we're not going to know about it, okay? Even if you want to give us kudos, we'll take those. If you want to sit there and yell and scream at us about something, please feel free. That's what we're here for, okay? Any guests this evening? Anybody that's first-time visitors, not a member of the club, but here? I'm just going to go around, stand up for a second, have you introduce yourself so everybody knows who you are.
Okay. My name is Stuart Lilly, Kilo Golf 4, Juliet Tango Romeo. I live in Winter Park. I live in the Westminster Retirement Club, which you probably know where it is. I've been off the air for maybe 6 or 7 years, but I've decided to get back on the air. As for anybody that lives in a community, there's a question of the antenna. So I have a very minimal vertical and apparently a very minimal signal, but I'm yeah, I'm working on that. Let's see anything else about me. I had a general class license when I was 15 years old, which was quite an achievement, but I let it lapse and then picked it up again later.
Welcome.
Thank you.
Thanks. What was your call sign again? KG4JTR, Juliet Tango Romeo. All right. There we go.
And I'm Robert Benson. I just got my tech and first meeting and just joined picking up my membership card and KQ4 JSQ and looking forward to learning about this. So it's been 3 weeks.
Congratulations.
Scott Kinney, my son Nathan. Paul's been hounding me to come here for about 4 or 5 months now, so I finally gave in and did it. I was a former comm guy for the Marine Corps and used to do some CB work when I was younger, but just thought I'd come by and see what it's all about.
Welcome. Hope you catch the bug. Anybody else? Right.
I'm Ken Smart, and I live in Longwood, and I've been on the CB radios when I was a kid with my dad a lot. He did the Heathkit and built them. We lived up in Alaska, And we did a lot of single sideband when I was in high school, but I haven't been in it at all. I have a lot to learn. I'm planning on taking the test soon.
All right, guys. Anybody else? Anybody else new or guests? All right. Welcome to everybody. As you can see, we kind of have a slight announcements that we usually do first thing, and then we go into a quick refreshment for donuts and refreshments, and then we go into our program for the evening. So, Bob, test sessions. Anybody? Got it up?
Okay, we had 10 people pre-registered, of which 9 showed up. 4 were successful. We had 2 new amateurs and 2 upgrades. So we had total of 4 that got something, and we had a bunch of people that failed a bunch of elements. But other than that, we got 2 new techs and 2 new generals.
Excellent. Congratulations, everybody. If you're one of the ones that are still here, congratulations for getting your ticket, and hope to hear you on the air soon. All right, a couple things. How many in the room went to the first Hams in the Park? Anybody here? A couple of you guys? Excellent. All right. I'm hoping that you guys had a fun time. I'm hoping that you guys will do it again. I know it's not the best time of year for doing this in Florida because of the wonderful humidity and heat and stuff that we have. I know that there's about 12 people that attended last month on July the 15th to Sylvan Lake Park up in Seminole County. It's happening again on August the 19th. It was in the newsletter. Hopefully everybody got a copy of the newsletter. For those that are new or not members yet, you can actually go to our website, top toolbar. I think it's under Club Tech and it's under the newsletters. You can actually download the current issue. It's usually posted Sunday evening before the meetings when it gets posted. But August the 19th is the next one, Hamson Park. It's going to be in Orange County this time at Moss Park, down in the southeast side of Orange County, east of Lake Nona. It is a pretty older park. It's been around for quite some time. Very tree friendly park. So if you're taking a wire or something to string, you should have no problems. In the newsletter, there's also a link for Mike. Can you do me a favor? Can you grab the door for the gentleman that's coming in? There's a link in the newsletter to sign up. And what that does is it allows Joe to get your information, and he can update you of any updates or anything, last minute changes, that type of stuff. So please use that link, get yourself signed up, and it's coming up on August the 19th, and it should be a fun-filled day. I wasn't able to go to Sylvan or Lake Sylvan on July 15th because of prior arrangements or agreements I had. August 19th, unfortunately, I'll be at Huntsville, Alabama for the Huntsville Ham Fest. So I'm really shooting for September to attend it myself, to join you guys. So looking forward to it. Hopefully we don't have any hurricanes, but please, I know that a lot of members have asked about doing this in the past. Don't remember all who asked because there's so many people have asked. And if you are one of them, please try to make some time to do it and keep this thing going. I think what we're going to be doing is going back between Orange County and Seminole County. It's kind of a joint venture with Orange County and Lamar's, or excuse me, Orlando Amateur Radio Club and Lamar's. And so we'll bounce back and forth between the 2 counties and different parks monthly. And the more, if it gets to be popular, it will continue. If attendance starts to drop off, then, obviously everybody's lost interest in doing it. I don't know what's going to happen in December. It's up to Joe, what he wants to do, or the guys that are helping him do it. He may do it still in December. A lot of times in December, because of the holidays and family gatherings and all that stuff, things get a little bit on the back burner for the month of December. Okay. Next thing I want to talk about real quick, ham radio classes. Prior to the pandemic, we done classes with Orange County Aries at the Orange County EOC, on average about 2 to 3 times a year. Then this little virus came to visit and everything kind of stopped. Just like the emergency brake went on and stopped. We are working on getting those going again, okay? And the reason why I'm bringing this up is because even though we're working on getting this going again, it probably won't happen until next year because Orange County's EOC is under a remodel project right now, which is scheduled to be done in October. But this is government work, okay? Well, it's supposed to be this year, they said. But you know how things go at times where things get waylaid and delayed and all that stuff. So we're not going to schedule one yet until we know that when the actual confirmed completion date is. And then we're going to schedule it several months after that because there's a process of advertising, getting people signed up, getting people the materials they need and making sure they crack the book open and study before the class. But why I'm bringing it up, we're trying to make sure we have enough people interested in the instruction part of it. Otherwise, we need a pool of people that we can call on that's willing to take a section of the Gordon West book that we use, the technician book, general class book when we do the general class, and hopefully eventually get into doing the extra classes again. Take a section of that book, a chapter, and do what's called basically a hot wash of that chapter, okay? It's kind of a cram session for the weekend. We go through the entire book over a period of Saturday and part of Sunday. And then at the end of Sunday, we actually do a test session and hopefully pass everybody, okay? But we need a pool of people. We had a small pool that was available prior to the pandemic. Unfortunately, since then, not so much of COVID, but I think age caught up to a lot of our individuals are no longer with us on that pool. So we're trying to make sure we build that up now. And we're working on doing it now so that way we're ready to go when we do a class. So if you are interested, I sent an email out to the individuals who are already on it and getting positive feedback from everybody. They're ready to get started again. If you are interested in joining us, send me an email. My first initial, last name at OARC.org is the easiest way to send me an email. And we'll get you on the list, okay, if you will. That does not say that every time we have a class that you have to sign up and volunteer for it. If you're available and willing to do it, great, okay? If you can't, that's fine too. That's why we're trying to build a pool of people or we have a better chance of getting people available for it. Again, the first class probably won't happen until next year and likely probably even after Hamcation. But once a date is set, then all the material has to be gathered and sent out to the people who are registered for it and stuff. So please let me know if you are interested. All right. So next question is, how many is actually going to the Huntsville Hamfest? I see somebody in the back there is awfully excited about putting his arm up. Bob's going, Michael and myself are going and stuff. So if you are new to amateur radio and this is your first time visiting our club, Hamfests are basically small little trade shows of amateur radio held in different parts of the country. We do one here in Orlando every year in February called Orlando Hamcation, which is actually the second largest amateur radio trade show in the world, okay? First being Dayton, Ohio, or Hamvention. Huntsville is the third largest in the United States, okay? There's a small little Hamfest over in Friedrichshafen, Germany that kind of falls third in the world, but Huntsville is third largest in the United States with about a total attendance of 5,000, okay? Although they've been trying to grow, and then that stupid little virus that affected everybody affected them too, and they're trying to build it back up again. Orlando Hamcation, being the second largest in the world, draws about 24,000 people over a 3-day weekend. This has 5,000, so you kind of see the difference in attendance levels between what happens in the United States. But if you've never been there, it's a great little Hamfest because being in August, it's all indoors. It's all air conditioned. It's in a great facility. If you're willing to spend a few extra dollars at a nice hotel that's attached to the convention center, you don't have to leave your hotel technically to go to the convention center. You kind of walk across the catwalk into the convention center from the hotel. So you don't have to get into a car and drive anywhere. That's what I'm trying to say. There's 418 flea market tables. There's commercial vendors, DX checking. There's forums. There's lots of stuff. If you haven't gone, and it's 2 weeks, 2 weeks from this weekend. So you have time to still look it up. And if you have the availability, you want to go, check it out. Their website is very easy, hamfest.org. Very easy. You don't have to, it's not hard to forget that one. Hamfest.org, check them out. You know, give them a try. I think you'll have fun. It's a fun event. Then we have ours coming up in February called Hamcation. And I'll turn the microphone over to Michael, who can give us an update of what's going on with Hamcation.
Everybody hear me? Okay, not too loud. All right. How many people read the newsletter? Hey, that's pretty good. All right, real quick, for the ones that didn't, first I want to actually welcome several new people to the committee. First one would be Sharon, KE4ST. She is coming on as the on-site ticket chairwoman. And her assistant for this year will be Diana, KO4VJ, coming on as assistant to help her out. Also back this year is Fred Fitt is coming on as an RV assistant chairman. I also have Bill, KO4IJJ. He's coming on to help James with forms. The final one is actually was on the committee, but stepped down as the chairman. Ed took over as the RV chairman, but Rich is going to actually stay on the RV committee as assistant chairman to help with all the pre-registrations and all the paperwork stuff and all that before Hamcation. So I'd like to thank everybody for stepping up and helping out this year. So like John said, we'll be at Huntsville Hamfest coming up in a couple weeks. How many people are on social media for Hamcation? How many people saw the announcement go out about our website being live? Good, good. For many years now, we've been trying to have the website go live on August 1st. On August 1st. It's me. Yeah. So since for several years now, we've been trying to make the website go live on August 1st. And this year we actually did it. So it went live last night or yesterday. And we have been very busy since then with sales coming in. For everybody also, the volunteer page is up. A lot of people's already volunteered on there. So go check that out also if you want to volunteer. I'm sorry, what? Oh, okay. And for the ones that do want to volunteer a little more than just Hamcation or during the show, I am still in need of some assistant chairs. I am in need of an IT assistant chair, a publications assistant chair, special event station, tailgate, and transportation. And one more security assistant chair also. So please, if you're interested in any of those, come see me during the break. I'll be here until after the meeting tonight. You can see me then. That's all I got. Any questions about Hamcation? Okay.
Well, the ultimate question is starting next month, we'll have tickets here. So if you want to buy tickets, you can still buy tickets here. Or if you want to go to the website, you can buy them on the website. So, all right, last thing I have before we start going around for board announcements and club updates. There's a small little event that we do in December called the Christmas party. Yeah, I know it's freaking 90 degrees outside. We're talking about Christmas already. but try to bring some cool thoughts to yourselves. Starting next month, Christmas party tickets will be available here at the meeting. They'll be available next month, September, October, and November's meetings. Plus, you can also email me and let me know you need some tickets. We'll send you a link to pay online. We'll hold your tickets and give them to you at the door. But tickets will not be available for sale at the door on December 2nd. There's the clue. December 2nd, folks, is the Christmas party. Same place it's always been. Same great entertainment. Same great food. Same wonderful dessert tables. Okay. So put it on your calendars now, December the 2nd. It's $10 for members and their spouses or significant others. Non-members are $25. If you haven't joined the club yet, it's $25, but those tickets will be available next month. So we generally had, I think the most we had one year was 130 in attendance, 120 to 130 in attendance, one year. Of course, you know, pandemic kind of made that drop a little bit. Last year we came back up above 100. So it's usually a pretty good event. Looking forward to it. Okay. So if you can have the time, make sure that you put it on your calendars. Doors open at 6 o'clock. Dinner is served at 7 o'clock. Immediately after dinner, we do an awards program, give out some recognition awards, some great door prizes, centerpieces. That usually a lot of people go, but everybody usually ends up going home with something. So it's a fun-filled night. So please put it on your calendar. We'd like to make it a full house again this year. Okay. So December the 2nd, tickets will be available here starting next month. All right, that's all I have that here. Let me go around to the board members real quick to see if they have anything they want to update you on. And then we'll go around real quick to club updates. We'll take our break and then we'll come back to a great presentation. Michael, did you have anything else? Anna? Bobbin? Nope. Dean? Nope. Frank, since you're in the back. They're recruiting for volunteers for security and on-site tickets. There's going to be I can already tell there's going to be a divided house of security volunteers and on-site ticket volunteers. It's up. So again, like Michael said, the volunteer page is up and active. You can sign up on the page. There are description links at the top of the page. If you want to know what each position does, you can download or click on the link and it'll tell you all about that one position and stuff. All right. Who did I miss? Ed, anything? Nope. James? Bob C?
The testing people will be doing tests coming up on the 19th on a Saturday in Seminole County. And also, which I won't be at, I'll be at Huntsville, but they will be testing. And also, if they come and hook up with us, we're going to be doing a testing for a CERT group down at the Rosen Plaza or Rosen Center if they ever get back to us.
Have you heard any more, Christy, from the? Okay. I sent an email last week, but I never heard from anybody. So, okay. Yeah, I need to make sure that people start signing up too. All right. Going around to club updates. If you really don't have an update, that's not a problem. You just sit there and say, hey, I'll waive off the next month or whatever. But I like to give everybody an opportunity. QCWA. Come on up. Okay.
I'm Rich. I'm the president of the QCWA chapter. So just briefly, we have our meetings on the second Thursday. That's 10 days from today or whatever. And that's at the Perkins, which is about a block from HRO, 1 o'clock in the afternoon. Our motto is, even though QCWA is people that have been licensed 25 years or more, all are welcome. And we mean that. All are welcome. And it's a great group. We don't have any hidden agendas except a luncheon and a nice program. So that's about it. We also have a net on Tuesday evening. comes after the Seminole VHF traffic net. It's at 7:30, 147.195. You won't remember that, but it's on the websites, and see at 7:30 on the QCWA net. It's only a half an hour long, and all are welcome there too. And we mean that. So it's a good time, a lot of fun. It's just friendship. Thank you.
All right, Lamar's. Coming up after Lamar's, Short Ham Radio Group.
Hi, I'm Jim Robar, Vice President of Lamar's. We meet at Winter Springs Civic Center, and that's at 400 North Edgemont Avenue in Winter Springs, and it's about one block directly west of the Winter Springs Police Station, just to give you an idea where we're at. Any rate, tomorrow night, Stan Wood will give a presentation on a nano VNA. If you don't know what they are, stop and see me later. I'll tell you a little bit about them, but it ought to be pretty interesting. So there you go. Thank you.
I would say guys who carry little black books like that usually don't have those type of notes in them. All right, let's see, Short Ham Radio Group. Nothing? No new? Okay, face-to-face EOC meeting, Orlando's EOC on the 15th. All right, Clerk Onisert, anything?
Well, I don't have a little black book either, so. Our National CERT Conference, it's a 20th anniversary. They have about 22 people signed up for the ham testing on their side. Okay. It starts Monday and it'll go through next Saturday. They're going to have a CERT rodeo. And at that, there's several breakdowns of different departments, and I'm in charge of radio communication. So, what are you in charge of? Some sort of CERT.
All right. CFRA, Bobbin. After that, radio scouting.
Everybody, I'm Bob Nocero, W4KBW, President of the Central Florida Repeater Association. It's a small group, around 20 members. It'll be 100, right? We have a monthly meeting on the last Wednesday each month at Perkins on the corner of University and Forsyth in Winter Park. Get there about 6 o'clock. We just buy your own food. We don't buy stuff for you. 7 o'clock, we'll have just a 5-minute meeting at the tops of that, and then we ride through some more and you head home. We do have a repeater downtown Orlando, I-4 and Colonial area, about 400 and some odd, or 250 some odd feet up. It's 443075. It's analog and fusion with a standard 103.5 PL. The dues are monthly, $12 per person. If you and your spouse are hams, you can be $18 for the pair per year. That's about it.
All right, let's go with the radio scouting. After that, Shriners.
Hi, everyone. My name is Ken, KN4MDJ. So 2 weeks ago, we had 100 scouts all participate in some ham activities. 24 of them were from Scotland. We had another dozen from Canada, which is nice for international events going on. Our next big event is Jamboree on the Air. And unlike most places, they only do it one weekend a year. We do it 7 to 8 times a year. So we're actually doing the last 2 weeks of September and every single Saturday in October. So if you'd like to bring your nice little go box out and show some kids how to use ham radio, how to make connections using a battery without using a cell phone, we'd like to get the help. One of the little projects we have going on is we were given an entire campsite, 4A, to turn into a ham radio facility, a STEM class. We're right now working on grants. At some point, we're going to need some helpers, whether it be labor or radios or antenna and coax, all the different technologies we can get to try and build a nice first-rate ham radio-based STEM classroom. It'll be the first in the country with a radio focus. There's only 2 other STEM classrooms in the entire country, and there are more general science for those.
Excellent. Always busy. Shriners. After Shriners, we'll do Week Signal Society.
I'm Rod, W4VBK. We have our tailgate on the first Saturday of November, which is the 4th. Generally, 8 o'clock in the morning till noon. It's generally over by 11. So come out and join us. We have a good time anyway. We do have some door prizes. We are an official ARRL sanctioned event. So it's a good way to spend the morning, and maybe you'll find something you just can't live without. So we'll see you in November, and thank you for your past attendance. You've been very supportive.
Excellent. All right, We Signal Society, you got any updates? Come on up. After that, AMSAT, Deers, and Lara.
Need to get your towels out because lightning strike hit close to my house. And I've spent the last 2 weeks putting some stuff back together. Didn't lose any ham equipment at all. Just wanted to mention, if you've got long landlines going out to a garage or something off from away from the house, an antenna, and it attracts a little bit of lightning. But anyway, the beacons all seem to be working pretty good. We're still working on the 3.4. Wanted to mention that. We lost a part of 3 gigs. You're going to have to start paying attention to these microwave frequencies. They're going to be very valuable in the future. I haven't done the math, but we lost 50 megahertz of the 3 gig band, and it went for $22 billion. That's a lot of money for a few megahertz of spectrum. So that shows you how valuable this stuff is. Likewise, you ought to think about how valuable it is to you as well. That's just one of the bands. So they're taking big hunks, and this is G5. They're doing some strange things here and interfering with some other services, and they're already talking about G6. So they're going to suck up every bit of spectrum they possibly can. And if you worry about putting up a tower, look out. The cell phone people are going to have to put 6 times more towers up to support G5 when it comes 100%. So we may be able to not be seen at all putting up a tower. They're just going to be everywhere. Anyway, think microwaves.
All right, when they write those checks out to say Amherst radio operators for losing the bandwidth, make sure they get the spellings right of everybody's name. Yeah. Let's see, anybody from AMSAT? Any updates? Deers, Lake Amherst Radio, similarities. After that, Osceola areas if they're here, and then final we'll wrap up with Orange County areas. I just got off work.
Hi, I'm Frank Katie, 4EZW, President of the Seminole County Aries. I know we're still looking for a place to do training because our EOC is under renovation in the public room. So we're working on that. We're going to be doing an ICS 100 class. Right now, I'm doing a lot of fundamentals. Last week was our meeting. We talked about repeaters. We're going to be doing antenna basics in August, and I'm going to hand out some plans on how to build some easy antennas that you could do at home and you could try out for yourself, take them on deployment. We worked red hot and boom back on July 3rd at Cranes Roost. And we had a good turnout there and practice our deployment and ICS paperwork and all that kind of stuff. And our meetings are on the 3rd Thursday of the month at 100 Esslinger Way, which is the police department in Seminole County, right across from Napleton. What is it? Volkswagen? I keep thinking Audi. And so if you have time and you want to come and get into some electronics learning, stop by. And what else? Oh, the repeater, 147.090 on Monday nights at 8 p.m. And then the first Monday is Simplex at 146.46. Thanks.
All right, Osceola real quick, and then we'll wrap it up with Orange County, which will be really, really quick.
Jeremy, KQ4AFY, Osceola Aries meets on the last Monday of every month at 7 o'clock at the Osceola County EOC down on Parton Settlement Road behind the county office, main county office, and has a weekly net on Tuesdays and 145.35 at 7 o'clock.
All right, and then real quick, Orange County areas, next Thursday is our meeting night at the Orange County EOC. It's on the Shares Program. You want more information, if you're not a member, let me know and I will sit there and give it to you. I will go to our quick break. We're gonna do this one real quick. We're gonna do 10 minutes. Come back at 8:20 for a presentation on end fed antennas from theory to concept and on the air with these two gentlemen that are on our screen, Bob and Bob. It's gonna be the Bob and Bob Show. All right, guys, about 1 minute and 30 seconds and counting. All right, guys, if everybody will have their seats again, so we can get started. Tick tock, tick tock, tick tock, tick tock. Hello. All right. Before I turn it over the microphone to Ed so he can do introductions to our guest speakers. I wanted to remind everybody, if you have not gotten your door prize tickets, make sure that you see Rick as soon as possible to get your door prize tickets. We have a couple of different items tonight. Every amateur radio operator should have a dummy load to test your equipment. All right. Or in my case, I used to have my sister and I told her to put her finger here. Every amateur radio operator should have some parachute cord. Okay. Never know what you need to tie off or raise an antenna. Every amateur radio operator should have a handheld. Okay. FT4X. Every amateur radio operator has lots of IDs. You need another one. All right. One of our members is actually going to make up name tags for you. He's in the back, holding his arm up, his hand up. All right. So there's 2 vouchers. He'll do them for free for you. All right. So those are the 5 door prizes we have for this evening. Make sure you get your blue ticket. There is a blue ticket that ends in 925. If you had a blue ticket that ended in 925, I bet you check your pocket, you may not have a blue ticket that says 925 because I have it here. Well, hopefully I looked at the number. So if you're missing your blue ticket because you had one and it was 925, it would be right here. If not, there'll be one person that doesn't get a prize if we pull that ticket. Without further ado, Mr. Thralls.
Thank you very much. And Robert, Bob, thank you both for being there. Appreciate it. I'll keep the introductions short because I don't want to cut into your presentation time. Bob Glorioso, he's in the lower picture there. Was first licensed in 1955, and a few months later, he dropped his novice ticket, and they upgraded, and now he's W1IS. Has held that call since the late 70s. His wife, son, and daughter-in-law are licensed amateur radio operators, and he and his XYL are life members of ARRL. In 2019, he met an old friend while walking in a local wildlife preserve, Bob Rose, the gentleman in the upper left-hand corner. They found a common interest in designing and building antennas, so they decided to work together. They published many articles about antennas in CQ magazine, and their work on wire antennas is now available in a book form. Wire antennas, 160 meters to 70 centimeters, concepts, construction, and on the air. And you can find it at their website, ocfmasters.com, HRO Salem, hamradio.com, and I believe Amazon, or soon Amazon. Bob Rose wanted to get his ham license when he was in high school in the early 60s, but a neighbor who was a ham was having problems with TVI. So Bob's parents said, we're not going to be part of that. And he had to delay getting his ticket. He got an electrical engineering degree at the University of Maryland, designed radar signal processors for Raytheon, designed some graphics, multimedia chips for Digital Equipment Corporation, designed Xeon chips for Intel, raised a family, and retired. He wanted to stay involved with technology in retirement, so he turned to ham radio. When not doing amateur radio related things, Bob and his, Rose and his wife camp in Cape Cod, do nature photography and spend time with their three amazing granddaughters. I hope that, covers everything, gentlemen, in a short period of time. And we appreciate you being here to share your knowledge and your presentation on end-fed antenna from theory to concept and on the air. It's all yours. Thank you, gentlemen.
Let's see if I can get it up here on the screen. Hey, there it is.
Not yet.
We started to hear you, then we lost you.
Okay,
there we go.
There we go.
Let's see if I can find the. There it is.
Perfect.
Finally. That's the last one though. We want the first one. Nothing like starting out going backwards. I'm Bob W1IS.
I'm Bob AC1DSQ.
And as was said, we've been working together for quite a while on antennas. So NFEDs are one of the ones we've had a lot of time with and a lot of experience with, and are still getting new experience as time goes on. We're going to try a little history of NFEDs, and then we'll get on to the real nub of the question is multi-band single wire design. It isn't as simple as you think, and we'll show you why. Amongst them are band misalignment, end effect, and compromises. Just like everything else, life and NFEDs are a compromise. We'll deal with the impedance that varies with length, and how to wind a good transformer, and how to deal with higher powers. And we'll give you some specific designs for 80, 40, and 20 meters that you can build yourself. In history, NFEDs were actually created in the 30s. There's a diagram up there that's up in the upper right that is basically a schematic from that time frame. And they were tuned. And the thing that most important you got to watch is it says counterpoise at the bottom. That's kind of key. They were either single band or tuned with the transformer. And then in the 50s or so, antenna couplers came out, which are basically an L network of some kind. And the one that was most popular went with the Heathkit AT1 transmitter. Those of you who are as old as I am, I had an AT1. I got one of the first ones when they came out. And then I got the antenna coupler AC1, which was an end-fed antenna coupler, and they didn't tell you really how to use it. I had very bad luck with it. Didn't work very well. There's an unconnected light bulb there because in the good old days, it's just next to a wire. That's how we tuned our antennas, with a neon bulb next to the wire. And that's how you did it. You peaked the bulb, and that meant it was maximum output, and you were on the air. The problem was they really never specified how to ground it or counterpoise it or anything else, so you always had a hot chassis. I tried to ground mine, didn't work very well. So, but that's the first ones that really started getting things popular in ham radio, at least since the 50s. Today, we have multi-band NFEDs, and many of them started with low power, like the PAR and now Vibroplex line. They say there's no tuning necessary, and that may be true in some cases. They're transformer based, and all the transformers are wound the way this one is in this diagram, which is wrong, which we think is wrong. In fact, we'll tell you why later. And they sometimes, in fact, many of the manufacturers say counterpoise not required, and our response to that is, really? And we'll tell you why about that in a little later. Bob, you want to pick it up from here?
Yeah, okay. So this is a chart of, if we start with a frequency of the middle of the 80-meter band, 3.75 megahertz, and we look at the harmonics of that, they're all above the top of the each band. And it turns out that harmonics don't occur on integer multiples of the fundamental. They actually occur a little bit higher. So that exacerbates the problem. So if we look in the next column, we started with 3.55 megahertz, and we looked at, these are integer multiple harmonics. We look, and they line up pretty well with the other bands, but if you want to operate on the top of 80 meters, you got a pretty high SWR to deal with. So ways to deal with this, a lot of the NFEDs you see now, they cut the length, and offset center antennas. They start with a length that puts the 80-meter band at the bottom of the band. And then a lot of the NFEDs will use a little bit of a coil to help bring down the higher bands. So that's one way to deal with it. We have a different way. We can get a pretty good compromise for everything but 80 meters. And we have a way of fixing 80 meters without affecting the other bands. And so we can tune actually a little bit below the bottom of 80 meters. And the upper bands look good. And then we can bring 80 meters right where we want it, wherever we like it. So if we want to operate, 75 meters, we can do that. So let's go to the next slide.
Yeah, we do that with a capacitor.
Okay, you want to do this one, Bob?
Yeah. So they don't align. That's the first problem. And you can tune them with a capacitor or an inductor, and we use capacitors. But end effect is the other problem. This is part of the compromise. And if you look at the voltage and current waveforms are a typical dipole, which is what an NFED is. It's just, you can feed a dipole anywhere you want, middle, off center fed, or at the end, and they all have the same current and voltage distribution. And in this case, and in every case, the voltage is high at the end and low in the middle, and the current is high in the middle and low at the ends. Well, you think about it, current's going to flow through the wire, and there's nothing beyond the end of the wire, so you'd expect the current to be low. Not always the case. That's the challenge. So if you have a high voltage at the end of the wire, if you have high voltage anywhere, it's going to want to create a field, and it will create a field that will create a current flow to something else. And it does. There's enough voltage on an antenna that it will flow towards the ground or towards your house or anything else, because the voltage is high, so it wants to find something to mate with. And it will. And when it does that, some current will flow off the end of the antenna. Now your antenna looks longer than it physically is. And that's what end effect is. If you look at a dipole in free space, you see the electric field goes around the dipole, which is what you might expect, and it's over the earth. It couples to the ground as well as coupling to itself. So the ground is the interloper here. In fact, in every antenna, the unknown is always the ground and how high it is, and we all know that. We've learned that just from rules of thumb through the years. So the voltage at the ends has more current than the voltage in the middle. Because the voltage is higher, the current flow is higher. So it's electrically longer, and that's end effect. So the wire is electrically longer than you might think it is, and that lowers the resonant frequency and lowers the SWR at a lower frequency. So your lowest SWR moves down. So if you put an antenna low, like build it 10 feet off the ground and yank it up in the air, you're going to find out, wait a minute, it's not tuned where I thought it was. Well, that's the reason. End effect changes it. The lower you are to the ground, the more end effect you have. The general rule of thumb is that end effect increases the length about 2%. You want to do this one, Bob?
Okay, so now we're going to look at operating the antenna in a harmonic mode. So this is an antenna with the third harmonic. And so what we see is there's three dipoles, collinear end to end. These points in the middle where the dipoles join don't have end effect. So effectively, we've got three dipoles, and only one of them actually experiences end effect. So that says that the end effect in this mode is 1/3 as much as it is at the fundamental. So what that says is this resonance is going to be higher than an integer multiple of the fundamental. And this blew my mind when I finally figured it out. But That's why it's so hard to build a multi-band antenna. So anyway, so we decided to do something with a 40-meter antenna because you can operate a 40-meter antenna on 15 meters, but you don't get real good SWR on the 15-meter end. You're going to be high SWR. If you tune it for 40, you're going to get a high SWR on 15, and if you tune it for 15, you're going to get a high SWR on 40. So what we did is we stuck a capacitor 1/3 of the way to the end of the antenna, and that's where the current is a null. So for 15 meters, this capacitor does nothing. For 40 meters, it does something. And so this was the result. The 40-meter SWR is right in the middle of the band, and the 15-meter SWR is right in the middle of the band. And this was these curves are from our first attempt. We put this thing up and we measured that, and it's like, we're done. So that almost never happens, but
We looked at each other and said, holy whatever.
yeah, only deity of your choice. But anyway.
And it works great. And you can now switch from one band to the other, and you don't really need a tuner at either place, which is kind of nice.
So this principle is what we're going to use for the NFED, because it works on every even harmonic.
Okay. What's the impedance of an NFED? Well, a center fed dipole has an impedance from 40 to 75 ohms, depending on how high it is. And we'll talk a little bit about that later. But you need a 1-to-1 balun or unin or choke, whatever you want to call it, to make sure that it's a dipole, because otherwise current will flow down your coax right into your shack and create all kinds of havoc. So you need an isolation device, which is a choke or balun, and that makes the dipole a real dipole, because otherwise, with the current flowing down the coax, the waveform is not what you'd expect. It's different. It's got horizontal and vertical polarization, and it also has, ouch, because I got a shock from RF coming into the shack. An off-center fed is typically 20 to 33% off-center, and the impedance is roughly 200 ohms. And you can figure that out by just looking at the rate. Let me see if I can get this thing to go back a little bit. Look at the ratios of the voltage to current. You can see here it is about 70 ohms in free space over on the middle. And as it gets higher as it goes to the end, because the impedance is voltage divided by current. So at the end, the current is low and the voltage is high. So therefore, the impedance is high. So as you go down the wire, the impedance changes. And so when you get to roughly 20 to 33% offset, and we feed it 30% or 20% from the end, you have about a 200 ohm impedance. Now, no longer 40 to 75, it's 200. And it moves around, but it can move 10 ohms. It's hardly noticeable because it's a smaller percentage of 200. As you get to the end, the transformer gets really high. The impedance get really high. You need a transformer, a step up from 50 ohms to whatever the impedance is at the end. And what we've discovered is that unlike what everybody else says, we found that 36-to-1 as the ratio of the impedance at the end to the impedance that you want to feed is the way to go. Now, this is a diagram of my antenna that I'm using every day, and lots of other people are, as it turns out. It has a 36-to-1 transformer that transforms 50 ohms to about 1800, 2000 ohms in that range, and that's what the impedance of that antenna is. And so that's what it looks like. And then at 44 feet 8 inches from the transformer, we put a capacitor, and the capacitor will move the 80-meter resonant point up. So otherwise it'll be low, and that's how we solve it. Solve the problem of the two things getting in the way. The harmonics don't line up, and end effect changes as you go up in frequency, because you have fewer and fewer of your collinear dipoles
that have end effect. So it makes the antenna really look different than you might think. Now, we'll go in a little bit more some of this as we go on here, but Bob, you want to pick this one up? I think you did this slide.
Okay, yeah, so if you look at the impedance curve as you go out towards the end, it's like asymptotic, so it goes off to infinity theoretically. So we can use a 9-to-1. We use a shorter distance out to the end to match that. 16-to-1, we go a little bit further. 25-to-1, we go a little bit further. So whatever ratio we want to choose, whatever impedance we want to operate at, we can find a length where that's going to work. And so what we discovered with the 36-to-1 is that tends to make the frequency where you have resonance, zero reactance, line up with the frequency where you have 50 ohms. And so that's how you get the lowest SWR. So
that question doesn't get answered often enough, so keep that in mind as you're going through life as a ham. This is the transformer winding. I showed that before. This is the classic one. And this is a 7-to-1, which is 49-to-1 ratio, 7-to-1 windings. So if you notice that on the right where the connector is, the antenna connector is, the primary is wrapped around the secondary. It's tightly coupled to the secondary. That secondary, that's called a gimmick capacitor for those of you who are old enough to remember that term. If you need a little bit of capacitance, just wrap two insulated wires together and twist them tight enough to get what you want. By the way, a side thing here, I bought a new Honda van which has the low noise glass in it, and it's thicker than the glass on standard cars. And my end-fed driven 2 meter 70 centimeter antenna would not work because the spacing between the coupling plate and the plate on the outside that couples to the antenna was too big. Needed more capacitance in there. Couldn't do it with the capacitor they gave me. So I got a couple pieces of Teflon wire, wrapped them together, and twisted it until the SWR went down, and that's what I've been using for the last 3 years. So gimmick capacitors are handy. So what happens though now is you've created a low pass filter at the end of the antenna where the impedance is high. So if you have a 2,000 ohm resistor and you put 1 volt in, and you got 11 puff capacitor on the output, the voltage is going to be less than the input, which is not really what you really want here. You want it to just go straight through. So the bottom line is that kind of winding with extra capacitance that messes up the antenna, what it does is it becomes a low pass filter and makes the higher bands work not as well. So what did we do? Well, don't wind your primary over the secondary. Wind it in the middle, because in the middle of the coil, the impedance is lower. And so if you wind it over a low impedance part of the transformer, you don't need as much compensation. In this one, in this transformer, you need 100 puffs to compensate for the leakage inductance. And here you need 56. It cuts basically in half. So it's lower leakage, and the secondary is 12 turns. In this case, it's number 18 enamel, and the primary is 2 turns of 18 or higher. This one happens to be a piece of Romex we had lying around. We use that. This is a high-powered one. It runs about 500 watts. So this is an end-fed transformer. It's about 500 watts. The problem with end-feds versus off-center feds is that an off-center fed uses a transmission line transformer, which doesn't depend on the core as much. It uses the core as an inductor, not as a way of passing energy. As a result, it doesn't get as hot as an end-fed transformers. The transformers will get warm. And so here's what we use for the ratings. If you have 143 core and you wind that the way we showed you, it can handle 150 watts, but it'll get pretty warm if you make it continuous there. So if you're going to run digital, you want to run that one around 50 to 75 watts, no more than that. And if you put 2 cores in, well, your peak power, which is typically what you might get with a sideband signal, you would
you would cut the power rating again down for digital mode by about a factor of 3. And if it's 3 cores, which is what the higher power one does, you go 1200 watts peak, which you can handle with sideband. And for digital, it would be 400 watts.
And that's with the 52 megs core, which has lower losses than the 43.
Yeah, lower loss core is the 52. So the ratings are right there for the different kinds of power handling. So you got to be careful. If you're going to wind one, make sure you use a core that can handle the current and the volt and the energy that it's got to dissipate, because there's loss in the core. It's lost from between the primary and the secondary, and that loss is in the core. So the core gets warm. Now, here's the magic question. We got a 12-volt battery and a starter motor. We connected up the hot side to the motor, and we want to start the car. Now, anybody who knows anything knows that isn't going to work. So why in the world would you think that if you put a wire out and no place for the other side of the current to flow, that it wouldn't go somewhere? Otherwise, it won't work at all. So everybody says, well, it does work. It sure does. Why? Because the current will find a place. Whether you like it or not, the current will find a place to go. The counterpoise current will go. One side of this antenna that's in this diagram you could think of it as the counterpoise. If you move the antenna out further on the wire, you can have a shorter counterpoise on it at the end. Basically, an end fed is in the limit of an off-center fed. They're really pretty much the same, but because the impedances are high, you need different kinds of matching devices, and that's why I use a transformer on an end fed and a transmission line transformer on the off-center fed. So if you take one wire away, you don't have any current flowing. So that's what we have to say. So I know all these people say you don't need a counterpoise. Well, then if you believe that, I have a bridge in Brooklyn I know you'd like. So if you don't have a counterpoise, you put a wire up like that, the antenna will find one because that current's got to go somewhere. So it will go to the coax, which is where it often goes, to a tree, to the rig, and to you. Now I know that a friend of mine bought an antenna that the guy said you don't need a counterpoise. Just ground it. His shack was so hot, nothing worked. We couldn't make that rig work no matter what we did until we put a choke in it and a few other things. It was very difficult to make it work. You need a counterpoise. Want to take this one, Bob?
Okay, so we have coax, which actually has 3 conductors. The inside of the shield and the outside of the shield are separate conductors because of the end effect. I mean, of skin effect. The electrons tend to migrate to the outside surface, so we can bring power in from the rig, and that goes in the center conductor and the inside of the shield. And then if anything reflects back, it can go down the outside of the shield. So if the antenna is out unbalanced, you're going to get some of this I4 current, and that's going to come back to haunt you in your rig or change your antenna pattern or whatever, because the outside of the shield surface is going to radiate.
Whether you like it or not. So we take advantage of the shield, and our recommended design uses the shield as a counterpoise. And the way you do that is you put a length of coax that is roughly 0.05% of the wavelength. And so for 80 meters, it's about 13 feet. For 40 meters, it's about 7 feet. And so you put your antenna up, you go to the transformer, and when you connect to the transformer, you then connect the coax to it to drive it, and that is a 13-foot piece of coax with a connector on it. And then you go to a 1-to-1 union, choke, balun, whatever you want to call it, that has about 30 dB of isolation, and you connect it there. And then the current flows on the outside of the coax. You want it to do that, and then you stop it when you don't want it to run any further, and that becomes the counterpoise of the antenna. And not only that, because you've stopped it, it doesn't go into the shack. I have one here, as I said, and my antenna runs right alongside the shack here. It's about 50 feet up, but it's right over the shack almost. I have no RF coming in. Luckily, I don't have any transmitted RF, but there's nothing coming in the cable. It's clean. So that's what we do.
So one thing I forgot to mention, this 36-to-1 transformer ratio gives you the low SWR if you have a counterpoise that's about 0.05 of your wavelength of your lowest frequency. So that's how we get the number for the length of the coax there.
Okay, and I think that says it here. And this is the diagram for two antennas. The one on the top uses actually a wire counterpoise. And the counterpoise can go any way you want. You can go out and down. You want to keep it away from the coax feeding your antenna, feeding your rig. But it can go out to another tree and look like an off-center fed antenna. It doesn't make any difference. But 13 feet would go out, and then the rest of it would be would go the other direction. And that's the top one. And then the bottom one shows coax. That's a 40-meter end fed, and we use the coax for the shield for the counterpoise. Now it'll work. We have loads in there, and the capacitor load moves the. We tune the antennas for the high bands, as Bob said. We set their length basically based on, we go up to 15 meters and tune it for 15 meters. If you get the 15-meter band looking like less than 2-to-1 across the band, which you can easily do, it'll line up that way on 40 as well. So they kind of follow from 15. You go to 15, tune the antenna for minimum SWR across the band of 2-to-1 or less than 2-to-1. And then you go down to 80 meters and you stick the capacitor into the antenna. And what will happen is when you're without the capacitor, the antenna will be tuned just at the bottom of the band or below the bottom of the band. You put the capacitor in. In our case, we use 150 puffs. Your lowest frequency of lowest SWR will move up to anywhere between 3.65 to 3.75, somewhere in there. Mine is about 3.73, I think, right? And that means you get roughly less than 2-to-1 SWR across the band, which is pretty darn good on an 80-meter dipole.
The nice thing is, if you like to operate 75-meter phone, you can use a slightly smaller capacitor, and it'll put your resonance up to the top of the band.
Yeah, in fact, we built one for field day for our digital group, and we said for the frequency, the minimum SWR frequency, I think at 3.6 megahertz or 3.62 or something like that, and they run just fine with it that way without a tuner on the rig. That's like 1.5 to 1. So these are the curves of the 80-meter one. I think this is mine, actually my antenna. And as you can see, it's pretty good everywhere. Only place it has a problem is on 30 meters, where it's above 3-to-1. And it doesn't work on 60 meters, which is a shame because there's a lot of 60-meter activity around here. So, but it will work if you load it up with the tuner and don't drive it too hard, to too much power. And on 60 meters, you can only run 100 watts anyway. So you run it something like 75 watts and you'll be fine. I measured mine today. I put a new transformer on mine today, and I measured mine and it's on 17 meters, and it's just a little over 2-to-1 across the band. I did some tweaking on it, but other than that, it's pretty good. As you can see, if you tune 15 meters, the others will kind of come in for you. If you don't like 40 meters, then just get a different antenna because that's beautiful. And 12 meters is good, and it does pretty well on 10. And if you build one with a low power transformer, which would have lower loss, you can work them on 6 meters. And we do that. We've done that on 6 meters, and they work pretty well. You have to run them at lower power, about half power. But that's what you can do. You use a different transformer. And this is the 40-meter end fed curves. And you can see it. One of the things people say, how do I get 30 megahertz and 30 meters and 12 meters and other WARC bands better? The answer is, Bob says it all the time. You get what you get, right?
Right, these are not harmonic frequencies, so you're at fate's disposition here.
Yeah. But this stuff works pretty well on 40. This is one that we use at field day for our GOTA station, which usually is on 40, 20, and 15 most of the time. And they do quite well with it. This one is with the low power transformer, so it does work on 6 meters, and the SWR is low. A lot of that reason why it's low is because there's losses in there, but it still radiates, and that's a lot of the other antennas that are built differently don't. Okay. We're going to be, I guess, heathens here or something, because we're going to tell you how to improve the ARRL 40 meter NFET. A lot of them are out there, and I'm glad they're doing it, but they haven't done a good job. And I just got a report today from a friend who analyzed the transformer quality that they're using, and apparently the core they're using isn't very good either. The loss is very high. Anyhow, change it to a 36-to-1 transformer with the primary over the secondary, and solder one end of the secondary to the shield side of your coax connector. Solder a 56 puff capacitor across it. Get a 7-foot piece of RG8X or whatever else you're using, and get a Unin, and you can buy them, but if you're going to use it for portable use, might want to make one. There are instructions on how to do it on our website, ocfmasters.com. And then to tame the SWR placement, use 150 puff capacitor, 21.5 feet out from the transformer, and you'll have a pretty darn good antenna. It'll be close to the SWR curves of this one.
I don't think we've mentioned this in this presentation, but when you put one of these capacitors in there, you have to have a bleeder resistor across it so that you don't build up high static voltages and blow up your capacitor. So like a 2 megohm, 2 watt resistor would be maybe the sort of thing you'd want to use.
Yeah, that's exactly right. We sell some of them on our website, although we're kind of trying to back off from that. We like people to make their own, but they have a capacitor and a resistor across it, and they're mounted on an insulator, so they're ready to go. But this is one that's kind of a cute antenna. This is a 20, 15, and 10 meter NFET that we built primarily to be used in attics or for portable use, although it could be used anywhere. In fact, one of the first people that saw the design and built it didn't want it for either. He put it up permanently in his backyard, and it worked fine. It's a little different theory about it, because from 20 meters to 15 meters, it's not a harmonic, so you've got to get the thing to be resonant. And the only way you can do that is with a trap. So there's a trap that you tune first for 15 meters, and then you tune it for the rest of the bands, and it works really quite well. So it's a neat little design, and use an 82 puff load to fix 20 meters. So it kind of fixes all the frequencies. You fix 15, and then you fix 20 meters, and then you fix 10 meters with the end. That's pretty close to what it is, although they do interact. You have to kind of make a couple passes at tuning this. Anyhow, that's a 20 meter, 15 and 10 NFET. If you build it the way there's an article on it. Let's see, where is that article? Oh, I think we sent. It's in our book, actually. This antenna is in our book. But I think we sent a copy of an article that we wrote about it to the league, but we haven't heard from them for months. They don't respond very quickly. Anyway, that's it. And this is the list of our latest publications. 70 centimeter kitchen array, which is made on a cookie cooler. Amazing antenna. I got 11 PI gain on 70 centimeters, and we measured it. It's really kind of fun. Takes about 2 hours to build. It's not much of a build. We showed a friend of ours the design, and next time I saw him, he had it in his hand. So he said, "Here, works really well." And this is our book, Wire Antennas, that is available at our website. And Ham Radio Outlet is carrying it on their website right now. I don't know how long they're going to do it. And they have it at the local store in Salem, New Hampshire, but I don't know where else they have it. So if you go to another one, ask if they got the book. That maybe we can get them to sell it there. Our goal in selling the book and doing all this work was not to make $1 million. It's to have fun and help other people have fun. So that's our presentation, and we're ready to answer questions if you have any.
James. Yes, sir.
The two Bobs. Okay, my name is James. The models that I see, you guys have rooms that have these completely one end to the other, whereas we're struggling with an end fed, just trying to get it to fit on our property. So it's got 2 turns in it to try to make it fit on the property. What effect will that have? How do you get around that, or you don't even try?
Well, no, the nice thing about an end fed is you can kind of screw around with it. If you have a couple trees, you can wiggle it through it. The other thing you can do is make an inverted L out of it. You won't need counterpoise on that inverted L. And we configured, actually we've run mine here, the 80-meter one, on as an inverted L, so it doesn't take much room at all. You can go, 30 or 40 feet up and 60 or 70 feet or 80 feet or whatever it is, horizontally, or whatever you can do. You can even make a U out of it.
It seems to be pretty immune to that sort of thing. I was surprised. I simulated the inverted L, and I didn't change anything from the flat antenna, and it was pretty darn good. It wasn't. I could probably make it better if I went in and tweaked it, but I really didn't have to.
How about the angle? Can it be too sharp?
Well, you can do 90 degrees. You don't want to do more than that, because then they start cross coupling and you have a problem. But you can go up 90 degrees and out. You have to retune it when you do that, because it'll change the loading a little bit.
Okay, how about the transformer in relation to distance from the ground?
Well, you want to make sure that if you have the transformer, that the distance from the ground is such that nobody can touch the transformer, the unit, because that gets hot. That's got high voltage on it.
All right, I'm going to ask you to say that again. I had trouble hearing that.
Okay, the counterpoise, which would be your transformer, down to the unit, the end of the counterpoise where it touches the unit on the antenna side is hot. It's got high voltage on it. So what your limit of height is how to get it out of the way so somebody or an animal doesn't get in touch with it. That's all. That's your height minimum. We ran the 40-meter off center fed at field day as a sloper, and it was, what the heck was it? It was 17 or 18 feet off the ground. That was it. And then it went up from there.
It was the end fed, wasn't it?
Yeah, it was a 40-meter end fed.
Yeah.
Are there any other questions? Okay, got another question over here.
You'd mentioned the ferrite heating up. I was wondering if the capacitor heats up.
We haven't observed that. We do look at the effective series resistance, and we do design it so that you can get no more than a couple of watts in that. So won't heat up that much.
Yeah, well, there's 2 capacitors too. There's the one on the transformer, and that won't heat up because that's on a low impedance point. The one in line will heat up if you run a lot of power into it, but most capacitors, even if you're running 100 watts, almost any of the CVR capacitors, the snubber capacitors work fine. And they won't, their ESR is low enough and the current is low enough that you won't see any heating there.
So, yeah, we used ceramic capacitors that have a really, really low ESR. And you can also use RF snubber caps, like they're mica capacitors that like Cornell Dublier has a series, and they'll tell you how much current they can handle at given frequencies. So that's another one that's okay for like medium power and low power.
This is Steve. Is this presentation available online?
No, but our article is available online on our website, ocfmasters.com, which describes the NFEDs. It's called A Deep Dive into EdFed Antennas. It was published in CQ 2 or 3 years ago now. And that article is on our website. So you can just go to ocfmasters.com and look at publications, and you can download it if you'd like. And we encourage you to do that. Go get it.
Any other questions? Okay, I don't see any more hands at this time, but thank you very much, both of you. Great job.
You're welcome.
Okay, well, thanks for the opportunity.
All right. All right, a couple of last things real quick. Michael, did you want to talk about awards real quick? Awards? Also, was kind of reminded about the Christmas party, something that we do. For those of you that have been with us before, you know what this is. For those of you who have not been with us at a Christmas party, we collect toys for Tots. So all we ask that you pick up a small unwrapped toy for boys or girls and bring it with you. Doesn't have to be a lot of money. You can go to lots of different places and get something very inexpensive. And just bring it with you. We'll have boxes for you to put the toys for Tots in. And we usually 2 to 3 boxes in the past of toys for Tots. And it's greatly appreciated. So, Michael, words?
One thing I forgot to mention earlier about Hamcation. All right. One thing I did forget to mention earlier about Hamcation, the awards are up and live. So you can go up there and make nominations. It's the Carol Perry Educator of the Year Award and the Gordon West Ambassador of the Year Award. All the information is on the awards page. So if you know of anybody that you would like to nominate, please go up there and do so.
Might be batteries. Okay. So before we do the drawings, I just want to make sure everybody knows next meeting, Wednesday, September the 6th, here at the fairgrounds. And our presentation is Anthony Luscri. Everybody knows Anthony. Anthony has done a couple of presentations for us before. That's Kilo 8 Z Tango. And he's going to do one on how to make that QSO. So if you want to learn how to make QSO contacts, be a great presentation. Michael, you gonna do drawings? All right, as always, which I already know which one's gonna go first, but I don't want to change the rules because then people say, why you change the rules and stuff. So as always, what way we've done in the past, if your number is selected, it's your choice on what prize you get. Okay. I just want to make sure that everybody knows that these vouchers were donated by Joshua. It's in the back. And he is gonna, it's a voucher for a call sign name tag. And there's a couple different logos he can put on for you. So please, if you get that, take up on that offer. Help us out.
All right, first up. 6950
Teresa. Your choice. Oh, the dummy load. I was wrong. That doesn't happen very often.
All right. Next up, we'll lower 696. All right, I guarantee you next month we'll have a new thing up here. 6945. 6945. Going once. 6945. Oh, Jim in the back.
Come on up, Jim. You got a choice between a radio, parachute cords, or one of the name tag vouchers, I should say. One of two.
All right, next up. 6960. 6960.
Harry. It's an empty box. It's just a joke. Actually, that is not the handheld we were gonna get. We were gonna get the FT60, was it?
Yeah, but they were out of stock.
Somebody a week ago came and bought 20 of them. 20 of those radios, and they were out of stock.
All right, next up, 6947.
6947, come on up.
All right, and the last one is gonna be 6970. 6970.
Excellent.
All right, another thing John forgot to mention about the Christmas party is we have lots of prizes. It's me. Lots of prizes.
All right. All right, what he's trying to sit there and say is we do have lots of door prizes that we give away. And it's usually, again, pretty much everybody that comes to the party walks away with something, okay? Everybody doesn't walk away with a 705 or a 905, but everybody walks away with something, okay? So it's always a good event to attend, right? I'll just say this way, if your religion doesn't believe in Christmas, come into the holiday party, okay? We have lots of fun that night, okay? Thank you, everybody. That's it.